My name is Stephanie Spera. I'm a postdoc at Dartmouth College, and I'm going to be talking about something completely different. How we go about quantifying 2 decades of expansion in Brazil. So I'm an environmental scientist. I'm interested in how the landscape is changing, why it's changing, and what that means for the environment. And one of the primary ways I interrogate that landscape is through remote sensing. So I thought I would start off with this little animation of land use change through time in the Brazilian Cerrado. And we see that in a matter of just 26 years, that scale bar is 20 miles. All of the savanna, so everything that's brown here is a farm. Everything that's green here is natural savanna. We see that in 20 years, in this kind of large area, a large amount of land has been cleared for agriculture. I just want to also point out the farms here are huge. So if we're not thinking about smallholder African systems, we're thinking about driving around like in Illinois, except you'll see a palm tree in front of the field instead of, I don't know, grain silo. Okay, so Brazil is extremely important if we're thinking about food security, climate change, and development. And just so we're all on the same page, this is Brazil. And most people are familiar with the biome in the upper left-hand corner. These are the biomes demarcated, and that's the Amazon. And Brazil is also hugely important if we're thinking about global food security. So this graph is sometimes difficult to interpret, but basically this is showing Brazil's world share in agricultural production. So if we just look at orange juice, they are responsible for almost 80% of the world's total exports of orange juice, as shown by the purple bar. They're responsible for more than 50% of the production of orange juice in the world, and they're ranked 1 in both. So today I'm not going to talk about orange juice, I'm going to talk about mostly soy and maize and sugar, but this is just to highlight how important this country is if we're thinking about agriculture in tropical environments. And so all of this land for food has to be coming from somewhere. And when we think of where that's coming from, a lot of us actually think of the Amazon, and we think of pictures like this, right? But if we look at trends in deforestation over time in the Amazon, if we ignore the last 2 years, which I'm going to talk about later, so we have annual agriculture deforested on the y-axis and time on the x, we see that generally deforestation in the Amazon has been decreasing. But if we look at production of 2 of Brazil's major crops, soy and sugarcane, and this is planted area of soy and sugarcane. So we have soy on this left green axis and sugarcane on the right pink. We see that the land area has been increasing. So your question might be, where is this coming from? It's mostly coming from the Cerrado, which some people are familiar with, but in case you are not, the Cerrado is basically a woody savanna. It's about 2 million square kilometers, so it's bigger than Alaska. It's a biodiversity hotspot. And 5% of the world's biodiversity is in this biome alone. It has about half the amount of carbon as the Amazon, and about half of it has been cleared. So everything in gray has been already cleared. And if we just flip back and forth between the amount of land cleared in 2002 and 2016, we see that some of the things that were yellow, there's a lot more gray on this map, especially if we focus on that upper right-hand corner. In fact, over 5.5 million hectares have been cleared in just these 14 years. So I did my PhD in Rhode Island, and when you're in Rhode Island, you learn to measure things in Rhode Island. So this is about 18 Rhode Islands worth of land clearing. It's less impressive in Illinois, so I'm not going to say that. So I want to know what is happening on the landscape. And one of the main tools I use to do that is remote sensing. So I use data from the MODIS satellite, and I look at something called the Enhanced Vegetation Index and how that changes over time. So if you know what this is, that's great. If you don't know what this is, we can basically think of it as greenness. So if something has a high EVI, that means it is very green. If something has a low EVI, that means it's not green, not photosynthesizing. So just to sort of show you what the data I look at look like, these black things are the farms. So everything white here has a high EVI, it would look green to you. Everything black here has a low EVI, it would look brown or fallow to you. And these things are the farms. So during the dry season, when there's nothing planted on the landscape, farms have a low EVI, there's nothing there. During the wet season, when mostly soy is thriving, the fields have a high EVI, there's a lot of stuff being planted on the landscape, they're very green. So what you can do is you can stack up these images over time, and we can see how that greenness is changing. So we see in the, oh, and I'm just going to add, most of the agriculture in Brazil is rain-fed. About 99% of the agriculture is rain-fed. So I just wanted to add these bars that show where the rainy season in the Cerrado is. So we see in that yellow bar, whatever is grown there sort of greens up with the rains and then greens down as the rains cool off. We see in that bottom graph, we have EVI on the y-axis here, that has a low EVI, so there's nothing green on the landscape, and then we have these two huge jumps in greenness. So we have to figure out what is planted there. I can guess because I've done this for a while. What you actually do is you go there with a GPS and you drive for months and you find crop dusters and you go to all these points. And then you learn that that is what the phenological signal of Cerrado looks like. And this is what a soy corn rotation looks like. This first jump in greenness is the soy crop, and this is the corn crop. And what's great about Brazil is that it is filled with large-scale mechanized agriculture, and there are only a few rotations. So we have a soy cover crop rotation in green, a soy corn double cropping rotation in orange, cotton in pink, or purple, I guess, and soy cotton in magenta. So if you look at these 4 crop rotations, which are extremely common, you see that soy is always planted first, cotton is always planted second, cotton looks a lot greener than corn does and is on the ground for a longer period of time. So what you can do is you can write an algorithm that exploits these differences in phenology to actually map what's happening on the landscape. And then you also have to validate your data, but the maps that we've made are pretty accurate, so you can ask me questions about that later. But what you end up with are these annual maps of land cover change over time. And we're going to talk about 3 regions today. We're going to talk about Mato Grosso State, Goiás, and then the Mato Piba region. But just by looking at these 2 snapshots, and if you focus on the dark green, which is a soy single cropping rotation, and the orange, which is a soy corn double cropping rotation, you see not only an expansion of agriculture, but also a huge intensification of agriculture in Brazil. And because we have these annual data, we can actually make really cool maps. So here we have single cropping in black, double cropping in pink, irrigated land in blue, you won't see much of it, and sugarcane in green. If you really want to see sugarcane expand, focus on Goiás. And I'm really just going to talk about the large-scale trends occurring in this region, but this data set has proven pretty useful in actually studying the dynamics about what's happening on this landscape, what's driving these changes in land cover, and what that might mean for the environment. So let's start with Mato Grosso, which is essentially the original major soy producer in this region. So if you look at Mato Grosso between 2001 and 2016, we see not only an expansion of agriculture, but everything that was green in 2001 is now orange. Almost all of the cropland in Mato Grosso is double cropped. So total land in agriculture increased from 3 to 6 million hectares. That's huge. And there's been almost a 10-fold increase in soy double cropping in the region. And just to show you guys the temporal component, again, we see that expansion occurred mainly during the first half of the study period, and then really it focused on intensification. If you talk to a lot of people about this, they attribute most of this to the soy moratorium, which was an agreement signed between soy exporters that said, we're not going to deforest land for soy anymore, we're not going to export soy from newly deforested land. But I'd also argue, and I have argued in papers, that it might also have to do with land scarcity. So soy moratorium plus land scarcity might have given us this trend that we see. Goiás is a little bit different. Goiás is interesting because they've really upped their game sugarcane-wise. So in these 15 years, they've gone from Brazil's 7th largest sugarcane producer to their 2nd. So the total land in mechanized agriculture hasn't increased that much. It's not like Mato Grosso in that way. But there has been a large intensification of agriculture. Double cropping has increased from around 300,000 hectares to 1.4 million. But sugarcane has really, really increased. And if you think about other sugarcane growing regions in Brazil, like São Paulo or Mato Grosso do Sul, we see that every time sugarcane expands, there's a decrease in food production, whether that be through cattle, decreases in cattle land, or decreases in soy. But this really isn't the case in Goiás, which is a little bit interesting. So we have sugarcane area in white here. The amount of total land in soy has remained relatively stable over the time period, but double cropping has actually increased. and cattle stocking rate has increased. And Goiás has not been clearing much land for this new sugarcane production. Most of it's been coming from pasture. So again, we see that Goiás has been actually able to increase production through intensification. Mato Piba region, this is a little different. So if we go back to this map of land clearing, we'll see that this is really the region with any, this is the one with, if there's any Cerrado left, it's here. So they call it Mato Piba because the four states, Maranhão, Tocantins, Piauí, and Bahia, those are the initials put together. So it's like a 16-year-old acronym kind of thing. But this is where it's at, really, right now. This has been called Brazil's last agricultural frontier by their old agricultural minister. So between 2001 and 2016, agriculture increased from less than 1 million hectares to 2.5 million hectares. And you see, because this is a new agricultural frontier, there isn't much land that's being intensified, right? Most of it is still in that single cropping rotation, because usually you go from single cropping to double cropping. That's your normal trajectory. And if we're looking at where land is being cleared in the Cerrado, so this y-axis, this axis corresponds to the white line, the total amount of deforested area. And this is the percentage of these lines attributed to each region. So you see that in the beginning of the period in blue, Mato Grosso was responsible for a lot of the clearing in the Cerrado, but Mato Piba is in purple, and they're the big players in Cerrado clearing right now. And it lines up pretty well with their agricultural production. So this is just showing you the same graph, the same maps, but actually the temporal component of that all. In 2016, the producers were hit with a really hard dry spell. So that's why you see that big decrease in production. But this was just published in Reuters 2 weeks ago. They're really bouncing back. They're contributing large gains to Brazil's soy crop this year. So if we're thinking about where agriculture is going in Brazil, we're thinking about Mato Piba. This is where everyone's investing. The farmers here are still complaining because there is not the transportation infrastructure there. It's really hard for the farmers there and the producers to get the grains to the port. But this is where the ag sector has committed to investing time and money. So I just wanted to point out these large-scale trends because both Mato Grosso and Goiás have shown that they can increase production through intensification. And both of their parts, it's mostly because they ran out of land, good land, or the law said they couldn't produce anything else. But if we're thinking about Mato Piba as the next agricultural frontier, we're seeing that all this land is being cleared here. Maybe a thing to think about then is instead of starting with a small scale, we incentivize intensive agriculture. So instead of clearing more land, maybe we give kickbacks or short cycle soy or things to farmers that would incentivize intensive agriculture on the land that they've already cleared for this purpose. But if anyone's been following the news about Brazil recently, you've seen there's a lot of stories about the increase in deforestation, and people have shown, especially have shown that low exchange rates have been really linked to increases in deforestation. So it's going to be interesting moving forward if this country, with a low exchange rate, you're going to increase demand in a pro-business, pro-agricultural government, what that really means for conservation in this area. So that's a thing that we should all be thinking about, I think. The legality of the deforestation in the Cerrado. Yep, so Brazil is basically governed by something called the Forest Code. So if you own a piece of property in the Cerrado, you're legally required to conserve 80% of it. 80%? Yeah, Christine just... In the Amazon, sorry, that's what it was, in the Amazon. In the Cerrado, you're only legally required to conserve 20% of that, if you own that same amount of land. If you fall within this very interesting, in the Cerrado biome, but within the legal Amazon boundary, that ups to 35%, but that's it. I think only 3% of the biome is legally protected of the Cerrado, federally protected. When Brazil wrote its environmental constitution, they never talked about the Cerrado, so it's been pretty well forgotten about, unlike the Amazon. There's a lot more people know about the Amazon, so the conservation efforts focus on that, and I would probably argue that as a result, you know to invest in the Cerrado because less people know what's happening there. There have been some initiatives. In 2010, Brazil came out with this report that said we are going to limit deforestation by 40%, but I haven't seen anything that has actually shown that they've actually started to put money into that. There are some initiatives like the Roundtable for Responsible Soy that you could get certified for if you have proven that your supply chain is responsible. But I think only 30 farms in all of Brazil have taken that up because it's pretty costly. So the Cerrado is, compared to the Amazon, very unprotected. Yeah. So we've done some work on that. There are some biophysical constraints. You're not going to plant on high slopes because of mechanized agriculture. You need enough rain. You need this rain, temperature, and slope are some of the big biophysical constraints. But really, it's mostly just next to other. You want to be in an area where ag is already there. You're not going to just arbitrarily start in the middle of nowhere because that's pretty risky. You want to be close to infrastructure. And it also depends on the crop. Sugarcane has to be within 50 to 100 kilometers of a sugarcane mill because it degrades so quickly. That's not true of soy or corn or cotton. Cotton, you want to be on the lower edge of the dry season. So there's a lot that farmers consider, but it's always usually close to roads, close to other farms, and good agricultural land. Oh right, and no regulations. Yeah. That's just a given in my head now.